Hello, welcome to today's lecture on section 4.7, which is titled Complete the Square. Basically what this is a technique to solve quadratic equations. This technique can be used to do other things as well, but for today we'll talk about how it can be used to solve quadratic equations. So we'll start with our first example. Example number 1 will be to solve x squared minus 8x plus 16 equals 25. So here's what we do. And by the way, we're going to solve by completing the square. So the first step, step 1, to isolate the quadratic and linear terms from the constant term. So here is the quadratic term, because it has a square symbol. Here is the linear term, because it has just plain old x. And of course, those are constant terms, because they have no x. So let's do the isolation. X squared minus 8x equals 9. Step 2, we would take half of b, square it, and add it to both sides. Now this might seem a little confusing. But remember, standard form is ax squared plus bx plus c. So for our example, b is going to equal negative 8. Because you see right up above that negative 8 is a coefficient for our linear term. So if I do half of b, that's negative 4. Then if I square it, I get 16. Then I add to both sides. So x squared minus 8x plus 16 equals 9 plus 16. So basically got this. X squared minus 8x plus 16 equals 25. Now step 3. You want to factor the new trinomial and solve by square rooting both sides. So it's kind of an extension from section 4.5 we had to solve by square rooting both sides, and also from sections 4.3 and 4.4 we had a factor. So everything's kind of building upon itself. So if we look at it, x squared minus 8x plus 16, the factors is negative 4 and negative 4. Now there's a reason why it's called completing the square. This is a perfect square trinomial. So we were able to complete the square by adding the 16. Before you had x squared minus 8x, but by adding the 16, it's now a perfect square trinomial, meaning that these are identical. So we can consolidate it by writing this. Square root both sides. That's not what I wanted. I want to do a different color. Here we go. So you get x minus 4 equals, don't forget the plus or minus 5. So x equals 4 plus or minus 5. Basically that means you have 4 plus 5 and 4 minus 5. So you get 9 or negative 1 as your answers. So it's a pretty nifty technique. It can be very powerful for some stuff we can do later on in the year. We're also going to use completing the square to derive the quadratic formula, so you never have to memorize it. You can actually just derive it by using this technique that you just learned. Let's try one more example, and then I'll finish the video. So example number 2. Let's solve 2x squared plus 8x plus 14 equals 0. So we're going to follow the same steps. So first thing I'm going to do is isolate the quadratic and linear terms. So 2x squared plus 8x equals negative 14. But then here's where things get a little bit weird. Because a does not equal 1, divide all terms by a. So basically I'm going to have this. So you can call this like step 1b. And that was step 1a. So if I divide by 2, it's fair treatment. You're doing it to both sides, or everything, right? Or both sides, if you want to say that. Then we do step 2. We take half of b, square it, and add to both sides. So we have this. So that was step 2. And then finally step 3. We factor this sucker. X plus 2 squared equals negative 3. Root both sides. So x plus 2 equals plus or minus I root 3. Remember, we squared negative. You got to pull imaginary number out. So it's also an extension of 4.6, looking at complex numbers. And that's our answer. So I think 2 examples is good enough for today. We'll do some practice with this in class when I see you guys are in block number 2 this week. So that'd be Wednesday for E period, and of course Thursday for periods B, F, and G. Okay, so it looks like we're all set. So have a great day, and I'll see you guys later. Goodbye.